Hey everyone, Dan here. So the people have spoken. They wanted to learn about science. They want to learn about sound, the physics part of it, of sound. So I had a couple Twitter polls that kind of told me where to go with the next series. So I'm going to start a series today on acoustic radiation. Yes, that big scary words there. Acoustic radiation. I'm going to kind of break it down probably into like 3, maybe 4 videos. So at the end of these 3 videos, each can be about 4, 5, 6 minutes long. You really understand what acoustic radiation is and what we mean by doing that. So without further ado, we're going to go ahead and head to my whiteboard, and that is, ta-da! Here we go. What do you know? Yeah, that's some cool artwork. Friends send that to me. So anyway, so what we're doing today is acoustic radiation. And what that means is a lot of people have heard about this term called dBSPL. People, what the heck does that mean? What is dBSPL? Well, dB is a decibel. A bell is a measure of, basically a way of doing a logarithmic ratio thing. And deci means it's a tenth of it. And SPL means it's sound. So what do we mean? The dB is a ratio. SPL, what we ratioing. In this case, sound pressure level. What is the basic sound pressure level? Because if you're going to do a ratio, you have to do an upper and a lower, right? I mean, you got to have a comparison things. So what do we consider as 0 dB? Well, 0 dB is something called 20 micropascals. What the hell is a Pascal? Pascal is simply a measure of pressure. Remember, SPL is sound pressure level. Sound pressure level. So we're ratioing whatever sound pressure we're getting from our speaker, from our headphones, or whatever, where we're energizing it, relative to something that we call is 0. Well, that's 20 micropascals of pressure. And that's considered the level, the quietest amount, the lowest amount of pressure that your ear can detect, that you can physically hear. There are pressures that are below that, obviously. You can go all the way down to 0 pressure, like in outer space. But you can't hear that, so you can't perceive that as sound. So this is kind of considered like the lowest level. So what is a Pascal? People are like, well, okay, that's great. That's fine. What's a Pascal? Isn't that like a programming language that died in the 90s? Yes, I'm that old. I learned Pascal in college. Anyway, so no, what Pascal is, 1 Pascal, and you often see it approximated as PA. It's 1 Newton per meter squared. So that's for you people in the UK or metric based. It's a Newton of force over a square meter. What does that mean for the rest of the world? Like the world that actually sent men to the moon? It's about 0.15 milli-psi. So it's basically, you need about 6,700 pascals to equal 1 psi, and that's pounds per square inch. So a Pascal is a very, very low level of pressure. Very low level of pressure. You can see that. We're talking 20 millionths of that level is what your ear can hear. So very, very low levels of sound. So when we back it up, when you see something say dBSPL, what that means is how many SPL are you getting out of it relative to 20 micropascals. So we're going to do something really quick here. How do we calculate that? Well, we come on down here, and the dB SPL equals 20 times the base 10 log of P measured divided by 20 micropascal. That's it. So if I measured 1 Pascal of pressure, I get 1 divided by 20 millionths, which is, a very big number. What is that, about 50,000 or something like that? Take the log of that, multiply by 20. I'm going to end up getting right around 94 dB SPL or something like that, I think, is what that comes out to. So that's how you actually calculate it. So if I give you the dB SPL, I can do that. If I similarly want to know the pressure measured, I just do the inverse, which would equal 10 to the, I don't need that because we're not there, 10 to the dBSPL divided by 20. That's how I calculate the pressure. So if you tell me how strong a pressure is over an area, I can ratio it to my reference of, remember, 0 dB is 20 mass. I can reference that, and I can tell you how much SPL that would be. Likewise, if you tell me how much SPL you have, I can figure out and tell you how much pressure you actually had in pascals. So to summarize, dBSPL is simply, hey, we're doing a logarithmic ratio of pressures, and we're looking for sound pressure level, and our reference is 20 micropascals. That's all this means. All that fancy stuff, that's all that means. So let's keep that in mind as we go forward. This is a good basic. The next things we're going to cover, so I covered dB, we're going to talk about what pressure really is, and then how actually pressure is radiated from a device, whether it's a sphere or a plane or whatever like that. We can get into that. That might break into 2 videos. It'll be a little longer. But we covered covered the first one, dB. So I hope you're no longer confused by what dB-SPL really means. It's decibels of sound. It's a ratio of what we are ratioing, which is 20 micropascals of pressure. This is what a micropascal pressure is, and this is how you actually calculate it. You take your measured pressure. This is how a microphone works. Basically, we know how much pressure is applied. It'll generate a certain amount of voltage. I can take the voltage. I know how much pressure that means. I do this ratio. Boom, I calculate out my dB-SPL. That's all there is to it. So with that, I hope this video was instructive. I hope you're going to learn more coming up, and we'll just kind of keep hammering these out. If you like it, give me a thumbs up. If you don't like it, give me a thumbs down. Tell me why. I'll adapt it as I can, and I just want to help educate people on what goes on with sound so you all know more about it. That's it for today. Dan Wiggins, Periodic Audio. Check our stuff out. We've got great gear. We have award-winning gear. It all sounds phenomenal. I think you're going to enjoy it. See y'all later. Bye.